Thanks for the Northern Ireland Geothermal webinar series to invite me to explain and give what we are doing in the University of Galway with this geothermal heat pump project. So let's get started. Let's see if I can. Okay, so I need to kind of close this banner here, I think. Yeah. So I'm just going to introduce the project. So this is a brief overview of the project. For those who don't know much about Galway, we are at the west of Ireland, but I think most of the audience it's local or Irish. So you'll be familiar with the formerly NUIG campus. So this is the kind of the ring here in the North Campus. Is the engineering building. It's called Alice Perry Engineering Building, and this is on the bottom part of the picture. This is kind of a sports center. It's called the Kingfisher. Here is the swimming pools. So this project started with an European project, H2020 funded project called GEOFIT, which have a lot of information, a lot of the technologies and the pilots of the project. These are the key facts of the project. So the intention is to provide with hot water to the swimming pool. The swimming pool water, it's related to 28. There was always an intention of using a district heating pipeline that runs here briefly to this street, to the back of the building, back in the engineering building, was to provide with hot water through this pipe to the Kingfisher swimming pool. This was not really realized, so we had the opportunity, the advantage of these projects to retake that idea and to provide with hot water using the existing pipeline. So the original drilling site was kind of at the back of the building, but that was soon discarded as it was too small for the loads. So the loads of the swimming pool were firstly in heat meters, because there was a lot of uncertainty about the type of loads and the statistical distribution of the loads that we were dealing with. So we did a bit of monitoring before starting designing the project. There were a lot of discussion and a lot of decisions to be made regarding where to put the installation. And basically, we came to the conclusion that there was no space. So we had to move and reconsider the whole project, and we decided to move the heat pump and the plant room to the Alice Perry building, to use a bigger field in front of it's called the lawn on the Alice Perry building, to use that, and to also connect with the existing pipeline. Okay, so all of these kind of schematics you will see in the pictures. How does it looks like now? The total heating demand is approximately 400 megawatt hours per year. We have a number of assumptions about losses, etc., and we had also to supplement with an air source dryer heater in the roof of the Alice Perry building. We have an initial layout of, and we have done 18 boreholes with an initial calculation for a DN32 pros, 150 meters deep single loop. Take into account that this project is only heating, so we are not balancing any loads through the seasons. Okay. We also had a core retrieve by Geological Survey Ireland of the whole 150 meters profile. We have 2 heat pumps of 40 kilowatt each at the evaporator capacity. So they are delivering approximately 100 kilowatts base load to the swimming pool. We are hoping to do gas-fired boilers and to replace the whole gas loads of the existing heating system of the swimming pool. There are a number of initial calculations for savings, CO2 savings. Always, like there's a difference if we consider existing mix. Also, this existing mix was something like 2018. In 2019, we need to, update once we start running, and with a total of 62% total primary energy reduction. We have two funders. One is the GEOFIT EU 2020 project, and then there is a capital investment fund from the University of Galway, approximately 1 million euro. What we wanted to achieve in terms of innovations is more than anything the instrumentation of the boreholes, where we can and we will monitor temperature of the underground over time and understand better how the underground works in terms of heat storage and heat extraction, heat rejection, and what's the effect, if is there an effect on the water on the underground. We have a number of activities now in the commissioning with the switch of the airs and the ground source with an online system. We had a fully instrumented pilot, and the main intention is to have this as a pilot, as a living laboratory concept for the undergraduate and postgraduate modules that we teach at the university. Somebody has drawn something here. I don't know how this happened. Okay, I'm trying to get to the next slide. I don't know how. Okay, so the layout that you have seen is quite fast. So the drilling field, so the ground source heat exchange is this one. So these are the 17 boreholes. Then there is the manifold. This is connecting to the plant room in the Alice Perry, and this building on the right side is the swimming pool, and this green line here is the existing pipeline that turns in. And we are doing this, the new underground pipeline, a connection chamber, and then the connection to the boreholes. This is the layout. This is straightforward, the layout, the PNID schematic that was sent to tender. And you can see the two pumps that were provided by the project, and then the complexity of achieving the double source, so the air source and the ground source. This is just one possible design. I must say it's a very flexible design that we got many opportunities to balance out with the air source and the ground source, and also even to use the air source to replenish, inject heat to the boreholes if possible. So it's a bit over complex. We wouldn't say this should be some solution, but this is what we wanted to achieve in the project. Buffer tank in the middle, and then subdivision with the district pipe. So everything in this project is different hydronic loops. Also another decision that was taken. There are science, but this was kind of the outcome of the consultants and the installers. Okay. Let's go to the drilling phase. I think this is kind of the busiest moment of the drilling. So we had two drilling rigs and you could see some of the details here. This drilling procedure is not always, it's not also the it's there are other procedures that with a close perimeter, and also with equipment that you could put a kind of bathtub enclosure here where you keep all the chippings, and also all the you control more the water and the bentonite, if you use any bentonite. You could see one of the boreholes here that's that's at the finished state. So the boreholes are drilled into rock, but the first something like 6 meters are encased with a steel pipe until you hit the bedrock. So there's something like 4 to 6 meters overburden, and then we can find there it's a geological unit. It's called Metacapro. So a lot of geologists here, I know they know more than me what does it mean, the granite world. And then we had also a lot of limestones there, like in the core retrieval we could see something like a kind of layers materials there. So it's always very important to have this core retrieved. And I also recommend for large investments to also have one test borehole where you can also do a heat extraction test, or a heat or a thermal response test, a heat injection test. It eases a lot all the decision making with all the uncertainty of the ground. What you can see here with the forklifts are the system that they use to fill the borehole with pea gravel. So this is something like a 4 millimeters gravel. Is the tiniest line. It's limestone. This is how they. It's just a cut in the back, and just this went through the borehole to the bottom of the borehole. Okay, a lot of annoyance, a lot of noise there. So we try to be as quick as we could, given the contractor capacity. Also, this is something interesting and important to have a look for large projects. So the collectors installation, this is kind of the collector installation. So there is a can with a wheel that they use to put the collectors. The collector is prepared and grabbed with kind of resistant tape. There is a weight here. I think that weight was kg. The weight is connected to the borehole, to the bottom loop of the borehole, and then it's lit and just dropped to the borehole. It's always important to control the pressure of the boreholes, and to equate the pressures. Also, if you are going to do any sort of grouting, it's always interesting and necessary to study carefully what's the resulting pressure of the at the bottom of the borehole. Okay, and to equilibrate the pressures. We had a Geological Survey Ireland drilling rig here during a couple of weeks, I think, doing a core retrieval. That was a very good experience. So we had all the cores exposed to the pool and to the students, and we could also understand better what's the geology of the site. After the borehole was drilled, we also decided to use that borehole, because that borehole is something very small at the end. So the annulus is like 75 millimeters to fit it with one of the equipments on the fiber optic. Talking about the fiber optic, so there was the intention of using firstly some sort of system temperature sensors on to monitor the behavior of the underground over time. And there were a few options there considered. I must say this one of the things we explore a bit more were the options. So, but then there was a lot of difficulties with the connection of this kind of system. So this kind of systems are 100 pros that are linked in a cable, but at the end we find it very difficult to get electricity data to a remote place, but a distant place, and to have some kind of electrical equipment there that needs maintenance was something we really didn't like to do. So we look at the option of installing this fiber optic system. We had to know what was the best solution for that, and we seek advice among the partners of the projects. We ended up doing some two types of installations called a mini loop, which are just one cable that goes underground and just sits at the top, at the bottom, and then a continuous loop, so goes underground and goes up. So it's a double-ended loop. Okay, this is more or less a bit of more technical details of the trenching for tender. And some of the, I think I won't go into details about how the Raman effect works, etc. This is a bit of a separate talk. But this is, I mean, it's basically send a laser pulse, and then you read the indicator back signal that the light scatters in the walls of the fibers. So, and you have to integrate, you have to measure the time domain frequency of the scatter. The scatterbox has a range of frequencies, and some of these frequencies are very depending on temperature on the place of the fiber. So with this technology, you are able to measure every single, not every single point, but maybe every single half meter depth on the in the borehole. And for smaller cables, even at 35 centimeters distance. So you could have a very of the temperatures and a lot of data. And the most important part is that you could also infer what was the if there is any on the underground water circulation using this technology. This is a bit of an overview technology of the equipment that is available in the market, more or less, and they're basically three things to look at. One is the cable. The cable needs to be reinforced. It's something like a specialized cable. It's not really a cable that you find for your connection to the broadband, but I mean the fiber is, but the rest of the cable is a bit more prepared for heavy handling. The terminations that we were talking about, and then the interrogators. This is the machine that sends the laser pulse. Okay. In order to have one of the systems installed as a double end loop. So one cable that goes inside the loop and that's the whole loop at the end. We had to manufacture design and manufacture some of the clamps and some of the equipment that goes underground and make sure this doesn't move and fits the borehole diameter and it goes smoothly. At the end, it ended that very, very well. Here on the right hand side, you can see the second borehole that was double ended. So this was a bit difficult because there was no other way of doing it but to unreel the cable, something like 150 meters, go back, get to the point where you had to pull the cable and then start feeding the cable. You can see this is kind of a red thing here, and then coordinate also with the unreel of the ground source loop, okay, of the collector. I think that was more or less the most difficult part of the installation, but we at the end we had some collaborations here internally with the fabrication labs and collaboration of everyone. You had to all the people involved, the electricians, the drillers, the building contractors, what was going on with the, and most importantly, they cannot be repaired. But at the end, it was okay, and it did up very, very well. So where are we now is more or less this. With this picture, I want to highlight that the civil works is do not underestimate the civil works. So there was something that's you have to consider carefully. So if you have very of connect, also the choice here to use the terrain. We had a lot of space there to work, but I that it took so much to handle all the different aggregates. This part of the borehole field, which is half of it, is already backfilled and filled with topsoil. And these are the conditions, and I'm gonna show you a bit of the picture. So they're not done the trenching. So you could see here in the right hand side for the connections of the boreholes. So this is also critical. You have to have a bit of plan here to allow for the machinery to move in corridors. Otherwise, maybe you can block yourself easily. This is the a bit of an overview of where are we. I think 2 days ago, so this is the kind of the violet line is just the connection to the manifold. Manifold is there. They're still handling the filling of the glycol of the boreholes there, and then there is the other connection pipeline. This pipeline is this green line that goes under the bridge here and goes to the other side of to the swimming pool. So this is the insulated district pipeline. So this is the leg that we are connecting to. This is also another choice to do it in legs of 6 meters, but you have to allow for the contractor to choose whatever they do better, and whatever technology is also available. We had a lot of supply challenges when and the tender in place and you award the contract. You have to deal with whatever is available at the moment. A good solution it's a very, the only thing is that it needs to be welded every 6 meters. Okay, A bit of details here on the entrance to the building of all the pipes. So this is the delivery pipe. This is the pipes to the manifold chamber. The return chamber, we decided to insulate the return pipe. So this is the crew suffering like a rock pitting. Insulation on the return pipe on the manifold. The manifold, this pipe is, in my opinion, a bit oversized, so the residence time of the fluid in this pipe connection from the heat pump to the manifold is a bit slow. It's to insulate very long. Like if you don't have much distance, it's not really that critical. Of course, the hot water needs to be good quality district piping, specialized pipe that has a very, very low heat resistance. Plant room. These are the two spoiled items here. So everything that you have seen is just to serve these two boxes here, which are the heat pumps. Decision also was made to have a buffer tank. This is probably the choice for many installers. You can get to more kind of simple installations, but it needs a bit more brave think or more knowledge about what are the loads on the other sides and how you can handle also the control of the heat pumps also. Okay, this is the air source, and this is some of the piping that is already finished and tested. Details, pressure independent control valves here. These are things that contractors they were free to optimize their design. Also, like these feeding stations for glycol. Sometimes you don't see for domestic or for small installations, and additions that we thought good things to have for the long-term maintenance, for the easiness of the maintenance, and for checking also the glycol content over the years. Okay. Some of the complexity of the installations, as I was saying in the first part of the presentation, this is unusual. So we had also another part in the integration and the swimming pool that I'm not showing because there's no much. There's only the pipes there. We are going to install a heat exchanger in the coming weeks. But in the source side, we are installing heat meters to measure the ground source side also. So we could work out the efficiencies of the system. And a bit of advice that I just write here as an outcome of the project. There's I don't know if I am on time, so it's I think Michel. So I will start. So investing in specialized software, it's always something good to recommend or tell your engineers to invest in specialized software for the ground source heat exchanger, but also for the calculation of the hydronic networks. The hydronic networks are something very there are battle for discussions between different trades, installers, and engineers in the field. So as they understand what they're doing, if they you have to either resource to simulation or to use specialized software to find best options regarding hydronic networks, because what I found out is that every single engineer has their own version of how the system should be designed and what's the priority for the system operation. And this has a lot of implications on the cost and on the way you operate the system. You have to think 25 investments, so decisions that are made for less likely not to be looking for ground source heat pumps. So it's a term investment. You have to look at the teams, at the people that you contract. So what are the incentives? So some of the incentives that people that intervene in these projects are just purely commercial in terms of selling things or advising things that they are just more familiar with, but without not really much scientific underpinning of with opinions or anything like that. It is a good investment to know your loads. You are going to do any retrofit project of a building with a lot of loads, and you don't really know what are the it's also a good investment. Heat meters installed and just to have a look at the loads and how can you price them. I would say for large investments, for large investments or for portfolio managers that want to start thinking about to go straight forward to a drilling company and get a test borehole and get a test done, because it will solve at a higher level. It will solve a lot of problems on sizing the systems and knowing what are you able to achieve with ground source heat pumps. This, I think, is something that I recommend to do it straightforward instead of dealing with uncertainty of calculations, design, and spending time or years with something that is uncertain. Sometimes if you get a bit of certainty, get more stakeholders to buy in on decision. This is something the more you know and the more uncertainties you cover, the more likely a big investment is like realized. Okay. Sometimes there are bottlenecks that are unachievable. So sometimes it's just like that, and you have to understand sometimes that the thing that you can do with ground, you need to balance what are you capable of doing with the expectations of the stakeholders involved that maybe don't have a knowledge about how this system works. So sometimes it's just better to have maybe a smaller system than no system at all, because of the black and white way of taking decisions. And sometimes with ground source is not like that. So you sometimes in many projects you can't just phase out 100% of the loads for some reasons, for the statistical distribution of the loads, for loads, or for just the building is not really ready, or the process is not really ready to take to store heat, or things that you have to analyze. Contract risk, it's also important, so you need to be careful about who takes the risks on some of the things that can happen in the project. And as I said, the hydronic is a battlefield as much as many other things with mechanical and electrical. Also, controls is another thing that there's plenty of opportunities to misdesign. And also very important is integration with the existing heating production sources, so mainly gas boilers in this. So you have to think about you're phasing out 100% of systems or partially, or also installing smaller systems that are more efficient, not old ones. I just broke it down into three kind of. One is policy. I think I have said that in other talks. We need to think, especially in Ireland, about policies and the authority as an enabler and a facilitator instead of in as a problem per se. So whereas in my opinion it shouldn't be that way, municipalities and encouraging to apply for this and to facilitating for ground source heat pumps. Drilling permits need to be streamlined. In fact, if you ask somebody if you need planning permission for drilling, I can tell you I have no answer about that. Nobody can tell you an answer about that. I've asked counties, county council, Galway County Council, different types of things about and there's no technical capability there to answer technical questions, for instance. So this could be also, this could lay in a, in an idle state and just be crawled for many applications. Okay. Understanding heat pumps, by I must say it was also one of the we have found to be the most difficult from engineering companies. Just straightforward refusing to do these sort of projects, having also engineering companies proposing all sort of design solutions. This is something to look carefully as engineers, if there are engineers here, and to think about system works, how you have to think with heat pumps. Okay, not everyone and not all of the engineers are prepared to think about heat pumps, as they come from a background of fossil fuel burning high responsive system. So the way you think and design these systems is different. Okay, you have to know your loads. Also, you have to know how to balance the loads and how to distinguish between loads and base loads, basically. I think Miguel is telling me there's only 5 minutes left, maybe. Okay.
If you could finish up shortly, just to allow for time for questions.
I think this is the last one. Investing in simulation-based designs is something that an engineering company has no incentives to. I think, in my opinion, or by the experience that I have in Ireland, is something that is just unfeasible. So the fees and the time and dedication is not really into the commercial scheme. So when you are asked about these things, it's something like it's really very difficult to have teams that to spend time and get resources to explore more design decisions. Okay. Important. Also, we need a lot of training on trades and drilling companies. And drilling companies, I think there's a lot to be done drilling companies from wells drilling to source heat pump drillings. Also knowledge about the products, the manufacturers, the technologies available a lot. So having able to help manufacturers that can support you any problems and that provide good and quality products and tested products, okay. I think the way ahead is just to commission the system, to have a heat extraction test done with the existing equipment, and we are going to do in the coming weeks, and start doing the operational based scientific part of the project, which is to explore model based control and to have this data repository and access for the for research purposes. Models on the University of Galway. For further proposals, just to close the loop on the renewables, it will be very good to explore within this laboratory what will be the options for thermal energy, and to expand the district heating network in the hot campus. We are also willing to participate in one of the annexes on the IEA and bring this project to the annex as a case study. And this is the last slide. Thanks for everyone.